Welcome to Lesson 1 of the Introduction to Python course. In this lesson, we'll be discussing Python basics, with a focus on how Python works, Python's place in the world of programming languages, Python literals, Python comments, variables and Python data types, simple modules, outputting data with the print function, and collecting user input. Let's start with a quick introduction. Python was created by Guido van Rossum, a Dutch programmer. It was released in the year 1991 and since then has become one of the most popular programming languages. Python is a high-level programming language. This means that it uses a syntax that is quite human-readable. Python gets translated by a Python interpreter into a language that our computer can understand. Some other examples of popular high-level programming languages include C#, Objective-C, Java, PHP, and JavaScript. Now, all of these other languages, unlike Python, share syntax that is similar to C. So let's take a look at some of the advantages of Python. First, Python works on different platforms like Windows, Mac, Linux, etc. This makes it extremely versatile. Second, Python has a simple syntax that is similar to the English language. This makes it super easy even for those with no programming experience to pick up and learn the language. Third, Python has syntax that allows developers to write programs with fewer lines than most other programming languages. Fourth, Python runs on an interpreter system. This means that code can be executed as soon as it is written. This makes prototyping very quick. And fifth, Python can be treated in a procedural way, an object-oriented way, or in a functional way. Now let's have a look at how to run Python. As mentioned earlier, Python can run on Windows, Mac, Linux, and other Unix-like systems. So the first thing that we need to do is make sure that we have the recent version of Python installed on our computer. So let's open our command prompt. As you can see, we now have our command prompt open. Now in our command prompt, we will type in the following command: python --version. This shows us that the version of Python installed in the system is Python 3.10.0. Now any version of Python that is 3.8 or later is more than enough to continue programming. If you have a much earlier version, don't worry about that. You can download a more later version for free from the Python website. The link to it is python.org/downloads. Just remember that after running the installer, run the same function again just to make sure that you have Python installed correctly. Now, one very important note. If you're using a Mac system, it is highly likely that your system already has a version of Python 2 installed. In this case, even after you install Python 3, you may find that running python --version will still show the Python 2 version. In this case, you would need to add 3 after typing in Python. For example, to use the same command, type in python 3 --version. Now, when you run this command, it should output the version of Python 3 that is on your Mac system. If it does, then you're good to go. And you should continue to use Python 3 instead of just typing Python for all future commands. Now let's see how to open the Python interactive shell so that we can program in it. To open the shell, all you need to do is type in Python. There you go. We now have the shell open, and we know that we are in the shell because of these 3 right-angle brackets. Now to test this, we can type in something like print hello world. So we will use the print function, bracket, quotation mark. We will say hello world. Then we will close the quotation mark in bracket and type enter. So there you go. Python has now printed hello world. To exit the Python interactive shell, all you need to do is use the exit function like this. So now we are back to our regular command prompt, and we know this because the 3 brackets are no longer here. Now let's talk about running Python files. So running Python within the command prompt of the terminal is quite easy, but it is much easier to use Python files so that we can save code, rerun code, and even share our code with others. So we'll get started with a very simple demo. First, let's have a look at a file that I have on my system. As you can see, I have opened the helloworld.py file. In this file, all I have is a little comment explaining what this code is doing, and then I have the actual line of code, which is print hello world. Now let's go back to our terminal. So first, we need to cd into the necessary file path. So in my case, it would be downloads, and then introduction to Python course content. I know, it's a very long file name. Oh, my bad. I have forgotten to put cd before this. There we go. So I'm now in the necessary directory. Now in here, I have my file helloworld.py. So what I'm going to do is type in Python space helloworld.py and then press enter. So this prints out the content from our file. As you can see, we have hello world given as the output of this particular line of code. To understand this a little better, let's get into an exercise. First, I will open the same file that I had opened before, which is the helloworld.py file. Now that I have this open, I will add an extra line of code here. So let's just print something very simple like hello again. And you know what? Let's add a third line of code as well. And let's say, how are you? All right, now we save this file and we go back to our command prompt. In our command prompt, we will run the same code that we did before, which is python helloworld.py. Now when we press enter, there we go. Python has now outputted the content of the file that we had just added in. So we have hello world as we had seen before, and along with that we have hello again and how are you? So it's as simple as that, running Python files. Now let's go back to our Jupyter Notebook. Let's talk about Python literals. A literal in Python is nothing but a value that is given in the code that the Python interpreter does not need to try and interpret, but should take literally. So, for example, if we left out the quotation marks in print hello, and if we just printed it as print hello without the quotation marks, Python would output an error. This is because it would not know how to interpret the name hello. But when we add the quotation marks, Python understands that hello is a string that is provided by us, and it needs to be printed out as is. Now we can use either single quotes or double quotes when creating string literals. All we need to do is make sure that the open quotation marks and the closing quotation marks match each other. Another thing to remember is that literals that represent numbers like 42 or 3.14 are not to be enclosed in quotation marks. So let's have a look at an example here. Let's say we use the print function, and within the print function, we say something like, love is patient, love is kind. Now, when we run this cell, we see that Python displays this, love is patient, love is kind. It's as simple as that. Now, if we had done this without the quotation marks, as I will just demonstrate here, and then I run this line of code, Python throws an error. Now it just says that love is not defined, but that's because it thinks that love is a separate object over here. If I had put this within quotation marks, it would continue to say patient is not defined and so on. So basically, Python does not realize that this entire thing is a string unless we feed it with quotation marks like this. Now let's have a look at Python comments. So you would have seen comments in earlier lines of code. If you remember, we had something that said this: say hello to the world. Right? You remember that, don't you? This is a comment in Python. A comment is written with a hash, which indicates that everything following it will be ignored by the Python interpreter. Comments are usually used to give instructions or pieces of information to anybody else who will be using the code or viewing the code, apart from the person who actually wrote the code. We also have multi-line comments, which are created with triple quotes like this. Yeah, sometimes, there's the autofill, so Python just throws in a bunch of extra quotation marks. But yes, so we put these 3 quotes, and then we can say something like, this is an example of multi-line comments. And then we close the quotes. So when we run this, we see that Python just displays the same thing, but not really as a code. Since multi-line strings generate no code, they can be used as pseudo comments. But in certain situations, pseudo comments can end up getting confused with docstrings, which are generally used to auto-generate Python documentation. Another way to write the same comment is like this: hash, this is, hash, an example, hash of multi-line comments. There we go. So as simple as that, we can just use a regular hash and we can write our comments in this way. Now we will move on to data types. So in Python programming, objects have various kinds of data types. The data type determines what an object can do, as well as what can be done to that particular object. So for example, if we have a data type of type integer, we know that this particular integer can be subtracted from another integer, but it cannot be subtracted from a string of characters. We have a little list here showing us the basic data types that are used in Python. Let's just run through this list. So we have Boolean, which is a true or false value. We have integer, which is a whole number. We have float, which is a decimal. We have string, which is a sequence of Unicode characters. We have list, which is an unordered sequence of objects similar to an array in other languages. Then we have a tuple, which is a sequence of fixed length in which an element's position is meaningful. Then we have a dictionary, which is an unordered grouping of key-value pairs. And finally, we have a set, which is an unordered grouping of values. We'll cover all of these data types in detail. Now let's get into another exercise. So in this exercise, we are just going to be exploring different data types. We'll be doing this using the type function. The type function is used to find out the type of a particular object. So let's get into the code. Now, the first thing that we need to do is find the type of 3. As you can see, it shows that 3 is an integer. Let me just add a few code cells here. Okay. Next, we will say type, and the second one was 3.1. This says that it's a float. Next, we have type and quotation marks and 3. This is a string. Then we have type, quotation mark, pizza. This is also a string. Then we have type, true. This is a Boolean because it can only give us two values, either true or false. Then we have type, bracket, quotation mark 1, quotation mark 2, quotation mark 3. Tuple. Then we have type, brackets, square bracket, quotation mark 1, quotation mark 2, and quotation mark 3. This is a list. Now we'll add one more cell here, and we will say type, brackets, flower bracket, quotation mark 1, quotation mark 2, and quotation mark 3. And it says set. Now let's just do a quick check with our sample solutions. So the first one is integer, second float, and string, boolean, tuple, list, set. We've gotten the same values, so we've gotten integer, float, string, boolean, tuple, list, and set. Now, in some cases, Python uses the word class when outputting a data type. In Python, class and type are basically the same thing. All right, now let's move on to variables. A variable is used to hold some data in the program's memory. In Python, variables are untyped. This means that we don't need to specify the data type when creating the variable. We can just assign a value to the variable, and Python determines on its own the type of that particular value that is assigned. Here's something that you just need to remember. So when naming variables, variable names are case sensitive. So by convention, variable names are written in all lowercase letters, and if there are multiple words in the variable name, these words are separated by underscores. So as you can see in this example, home underscore address. Now variable names must begin with a letter or an underscore, and they may contain only letters, digits, and underscores. Now let's come to Python keywords. It's important to remember that Python has a certain list of keywords because we cannot use any of these keywords as our variable names. This can just be confusing to Python and also to anybody else who sees our code. Now we can move on to variable assignment. So there are three parts to variable assignment. We have variable name, we have assignment operator, and then we have the value assigned, which can be of any data type. So let's try an example. We will use the same hello world script that we've used before, but this time, instead of outputting a literal with the help of the print function, we will assign a string to a variable, and then we will output the value of that variable. Here's what I mean. So let's say we have a variable named greeting, and to this variable, we assign the value hello world. Now, if we want to print the string, we use the print function and we input greeting, which is the name of our variable. Now, when we run this line of code, there you go. We have exactly what we wanted, which is the string hello world. Now, let's have a look at simultaneous assignment. So, Python allows us to simultaneously assign multiple variables. The syntax would look something like this. So, if we had two variables, let's say we have two variables, variable 1 and variable 2. Now, we can assign the values just by putting an equal to sign and then placing the values there. So it would be something like value 1, comma, value 2. That's it, as simple as that. So simultaneous assignment is usually useful when we need to assign several values at once. So for example, let's say we need to note down the first name, last name, and company name for a particular person. So let's give our variable names first. So that would be first name, last name. Sorry, we don't need to type an and. First name, last name, and company. Now we will input our variable values as strings, so that's why we put the quotation marks. So the first name can be, let's just say the first name is Monica, and the last name is Geller. Let's go ahead with Geller. And let's say the company is DigiSafari. So now when we print the first name, the last name, and the company, we get the output as Monica, Geller, and DigiSafari. Quite simple, right? So now let's get into a third exercise, which is writing a simple Python script. So in this exercise, we will create a new file and save it with any name that we want. We'll create a variable called today that holds the current day of the week as literal text. We'll use the print function to output the variable value. We will save our changes and then we will test our solution. So let's just get into it. So first, let's open a new file. So text file, right. So the first thing we had to do was call this file today.py. So we'll save it as today.py. Now we will create our variable. So our variable's name is today. And so let's say today is, what is today? Friday. So we will put this as the literal. And this will be the value of our variable. Next, we will say print today. Great, that's it. So we've saved this file. Now we can open our terminal. All right, so we have our terminal opened. So what we'll do is we will say Python and today.py. As you can see, we now have the content of our file written here, which is Friday. So we can confirm that our little simple Python script worked. Now let's go back to our Jupyter Notebook. Now let's talk about constants. So in Python, a constant is nothing but a variable that is not variable in its value, but remains constant throughout the program. That means that it cannot be changed during the program. Python doesn't really have any constants of its own, but as a convention, variables that are meant to act like constants are written in all capital letters. Here's an example. So I think we all know the very famous pi, right? Pi 3.14. So we define pi as pi, but in all uppercase letters. And then we type in the value of pi. So it's 3.141592 and so on, but let's just stop there. Next, we can consider the hexadecimal code for red. So once again, we define red in all capital letters, and then in quotation marks, since this is going to be a string, we will say double F and 0000. So there we go. We have now defined two constants, which are nothing but variables that will never be changed throughout the program. Now, let's see how to delete variables. Usually, we would not have to delete variables, but if we ever do, we can use the del statement like this. So let's say we have a variable a is equal to 1 and we print a. Okay, so that's fine. We have a equal to 1. Now let's say del a, and then let's print a. You can see that this throws an error and it says name a is not defined. That's because a has been deleted from this program and it no longer exists. Now let's talk about writing a Python module. A Python module is basically a file that contains some code that can be reused. A module can either be run all by itself or as a part of a much larger program. At this point, we will not get into too many aspects of reusing the code and modular programming, but we will look into some of the good habits. One is that we need to use the main function in our programs. Let's take a look at an example. So to write a function, we say def main brackets colon. Now note the indentation here. This indentation indicates that we are inside of this particular function. So inside this function, we will write print I am a part of this function. Then we will add another print line here. I am also a part of this function. Then let's add a third one, and we will say me too. Now we will exit this function by canceling out the indentation, and we will say print I am not a part of this function. After this, we will call our function by typing in main and putting the brackets. Now when we run this code cell, you can see that Python outputs I am not a part of this function first, and then it outputs I am a part of this function, I'm also a part of this function, and me too. Now what you need to note here is that this function does not run until it is called, no matter where it is placed in the program. That is why, even though we had placed the function above this particular line, since Python reads, the Python interpreter reads the code from top to bottom, and the function was called only after this particular line, Python first printed this line and then printed all the values of this function. So let's look at a few things that we need to note about functions. The first thing is that functions are created using the def keyword as you can see over here. The content that follows this keyword on the same line is called a function signature, which is this. The convention for naming functions is the same as that for variables. We use all lowercase letters and separate words with underscores. Third, in the function definition, the function name is followed by a pair of parentheses, which may contain parameters, and a colon. So within these parentheses, we can put a couple of parameters. We will get into that later. And then we add this colon here to indicate that we are beginning the content of our function. Fourth, the contents of the function start on the next line and they must be indented, as I had mentioned earlier. Either spaces or tabs can be used for indenting, but spaces are preferred. Or if you are using a good IDE, the IDE will do that for you. Fifth, the first line of code after the function definition that is not indented is not a part of the function and effectively marks the end of the function definition. As we have seen in this case, this line of code was not indented, which is why it came outside of the function. Sixth, functions are invoked using the function name followed by the parentheses. For example, indent underscore demo. So in this example, we had main and then we had the brackets. So this indicates that we are calling our function. Now, just a note, so we use main. There's nothing extremely special about it other than it is just convention to use it for a function. So a programming statement is a unit of code that does something. So for example, we can see in this particular code, there are two programming statements. The first one is this, where we assign a value to the variable. The second one is this, where we print out the value of this variable. In Python, statements are grouped using indentations. So like we saw for the function, lines that were indented below the function signature were a part of the function. So it's important to understand that changes in the indentation level would denote different code groups. So we need to be very careful when using indentations. All right, now let's have a look at the print function. So we've already seen a couple of examples where we have used this built-in print function to output data. So now we will see how to output a variable and a literal string together. This is because the print function can take multiple arguments. And by default, it would separate them all by single spaces. So let's have a look at the following example. Let's say we want to print hello. So we will have print, and now within quotation marks, we will print, we will give the different characters within the word hello. And we separate these using the comma. So we have HELLO. So now when we run this, you can see that we have hello, and each of these letters are separated by spaces. This allows us to combine literal strings and variables as shown in the next demo. So our next demo is this. We will define a function main, colon, sorry, wrong characters, colon, there we go. Now we will say today, and we will give the value Monday. Let's say it's Monday. Then we will print today is, comma, today, which means that we are saying that we need to print the value of the variable today at this particular point. And then we will add a period. Now we will call our function and run this cell of code. So as you can see, it prints out today is Monday, but there is an extra space before this period. In the following explanation, we will see how to get rid of this particular space. So now let's go to named arguments. So we have seen that with the print function, we can provide multiple arguments. These arguments can either be named or unnamed. So let's take a look at some more examples of different arguments that the print function can take. So let's do the same thing that we did before. And actually in this case, instead of hello, just to simplify this, we will say cat. And now we will provide two arguments. The first one is sep equal to quotation marks with a space in between. And the second is end equal to new line. Now when we run this, we see that it has printed out cat. Now let's have a look at what exactly our arguments did. So sep is short for separator. The separator argument specifies the character that separates the list of objects to output. The default value is a single space, so specifying sep equal to space within quotation marks doesn't really change the default behavior at all, as we have done over here. Now the second argument, end, specifies a character that needs to be printed at the very end, which is at after the last printed object. by default, this is a new line character denoted like this. We can use an empty string to specify that nothing should be printed at the end. So let's have a look at how we can use this separator argument to get rid of the extra space that we saw in the previous example. So we will have, right, so this was the example, wasn't it? So we will have def main brackets colon today equal to Monday, and then we will print with quotation marks, today is space, comma, today, which is the variable name, comma, quotation marks, period, comma, and now we will add the separator argument equal to quotation marks, and we don't put anything in between. Now we will exit our function, call it, and run this cell. So as you can see, we have today's Monday printed out, and there is no space between the last object and the period. Alright, so now let's see how to collect user input. So functions may or may not return values. So for example, the built-in print function does not return any value. Python has another function for this. This is the input function, which once again is a built-in function. It can take a single argument, which is a prompt for the user's input. Unlike the print function, the input function does return a value. This value is the input that is returned from the user as a string data type. Let's see this in the following demo. So let's define our function. Let's create a variable. And instead of assigning the date to the variable, we will use the input function, and we will add the question, what day is it? So this line, which is given within the input function, is going to be displayed to the user, and the user will then be prompted to provide some kind of input. Then we will say print, and within quotation marks, today is space, comma, today, comma, and we will put a period, comma, separator, once again, empty. Now we will call our function and run this. So as you can see, the program displays this question that we had provided, and it gives us a little input box. So we can give any day of the week we want. So let's say we give Wednesday. Now when we press enter, the program does exactly what we want. It says today is Wednesday, period. Simple as that. Now let's go to our fourth exercise, which is to create another script. So let's just, open a new script. So we'll just close these, and here I will open a text file, and let's call this hello.py. Now in hello.py, we will provide the following function. So def main, and then we will give a variable name equal to input. What is your name? So basically what this script needs to do is prompt the user for their name, and after the user has entered their name, we need to output a greeting. So once we ask them what their name is, okay, we will print hello, comma, name, comma, exclamation mark, comma, separator equal to nothing, and close the bracket. And now we will exit our function, and then we will call our function. All right, so we have saved this script, and now we can go to our terminal. So in our terminal, we will type in Python and hello.py. Now, as you can see, the user is prompted to type in their name. So let's just give a name here. Let's just say Bob. And there we go. We get exactly what we wanted, which is hello, Bob. A nice little greeting for this particular person. Now let's go back to our Jupyter Notebook. Now we will see how to read from and write to files. So we have a built-in function called open, which is used to open a file from the file system. We'll cover more about this in a future lesson. For now, we just need to know how to read from a file and how to write to a file. So let's have a look at an example. So we will start by opening a file. So let's assign this to the variable f. So f is equal to open myfile.txt. Then content is equal to f.read. This will read the contents of the file into this content variable. Then print content will print the content, and then we have f.close, which will close the file. All right. So now let's just have a quick look at this particular file. So we'll close hello.py. So let's open myfile.txt. So this is the content of the file. When we run this code cell, all right, we can see that the name myfile is not defined. That is because I have forgotten to put it within quotation marks. So now that I put it in quotation marks and I run this code, we can see that the content of that particular file has been printed over here. Now just remember that while doing this, you need to make sure that you are in the correct directory. In this example, I'm already in the same directory, but if this file was located in a different directory, you would need to provide the file path. Now let's see how to do the same thing, but using blocks. So we have with open myfile.txt as f colon content equal to f.read, and then print content. There you go. We get the same output, but we have done this in a block. So using blocks is a good idea because when Python reaches the end of the block, it understands that the file is not necessary anymore, and so it automatically closes it. This helps us to free up memory space. Now let's see how to write to a file. So within the open function, we can provide some more parameters. One such parameter is the mode parameter. This indicates whether a file is being opened for reading, for which we use R, or for writing, for which we use W, or for appending, for which we use A. By default, the mode is R, which is why we didn't need to pass this value in the first place while initially working with this particular method. But if you want to write to a file, we need to pass in the value W. So let's have a look at an example. So we will use our code block with open and we will say my file2, which is basically creating a new file, .txt, comma, and then within quotation marks, w, as f colon f.write hello world, and let's just add a couple of exclamation marks here. So now when we run this code, okay, so this works, right? Now let's open our particular file to make sure that this has worked correctly. So we'll say with open my file2.txt as f colon content is equal to f.read print content. There you go. So it has read the content from the file and printed it over here. Now, so basically, the code that we have just written will open a new file, myfile2.txt, and if it exists, it will override the file with the input that we have given. And if this file does not already exist, it will create a new file. So let's enter into a final exercise in which we will work with files. So here's the gist of what we need to do. We will open two files that contain lists of popular boys' names and girls' names from the 1880s. We will read their contents into two variables, and then we will create a file that consists of the combined content of these two files within that particular new file. So here's what we're going to do. Right, so this is the sample output. Now let's take a quick look at the two files that we have. So we have 1880 boys. So for simplicity's sake, I've only added 8 names here. So we have John, William, James, George, Charles, Frank, Joseph, Henry. Then we have 1880 girls, which contains Mary, Anna, Emma, Margaret, Bertha, Elizabeth, Minnie, and Florence. All right, so let's get to the code part of this. The code is very simple. All we need to do is with open 1880-boys.txt. So that's our first file name. We will save that as f-boys. Sorry, let's put it as an underscore. f_boys colon. Then we have variable boys equal to f.read. Sorry, f_boys.read. So these are things we need to be careful about, when writing variable names and things like that. Otherwise, we will end up getting errors. Now second, with open. Now we put our second file, which is 1880 girls.txt as f_girls colon and variable name girls equal to f_girls.read brackets. Then we have with open 1880 all.txt as oh right, so in this case we are creating a new file that would contain the content of both the first two files. So we need to obviously add the mode parameter, which in this case will be w for write. So we will put this as f, then we will say f.write boys plus new line just, for neatness sake, plus girls. Now let's open the file and display the contents. So we have with open 1880 all.txt as f, and then we have all equal to f.read brackets, and then we will print all. Now let's run this code cell. So there we go. We now have the contents of 1880 all, which contains a combination of 1880 boys and 1880 girls, as you can see over here. And just to confirm, we can see that this file has been created containing the list of all the names. So there we go. We have reached the end of this lesson. In this lesson, we learned how to work with Python, and we have understood the basic concepts of Python, including variables, how to output data, how to collect user input, and how to write simple Python functions and modules.